Touch your chin right now. Go ahead. Put your finger on that bony protrusion at the bottom of your face. Feel it. That hard ridge jutting out from your jaw. Every human has one. You, your family, your friends, everyone you've ever met. Every human who has ever lived. We all have chins. And here's what makes that remarkable. Here's what makes it one of the strangest mysteries in human evolution. No other animal on Earth has a chin. Not one. Not chimpanzees. Not gorillas. Not orangutans. Not any primate. Not dogs. Not cats. Not elephants. Not whales. Not birds. Not fish. Not anything. Only humans. Only us. And we don't know why. We can't explain it. Scientists have been studying this for over a century. Anatomists, evolutionary biologists, anthropologists, all trying to figure out why humans, and only humans, have this weird bony projection at the bottom of our jaws. And despite all the research, all the theories, all the fossils we've examined, we still don't have a definitive answer. The chin is a mystery, an enigma hiding in plain sight, on your face, right now. You've had it your entire life. You see it in the mirror every day, but you've probably never thought about it. Never wondered why it's there, never questioned what purpose it serves, because it seems so normal, so ordinary, so human. But that's exactly the point. It is human. Uniquely, exclusively, mysteriously human. And that's what we're here to explore. Why do humans have chins? What evolutionary purpose could they possibly serve? When did they appear? And why are we the only species that has them? If you're using this to fall asleep, perfect. Let the mystery settle into your mind as you drift off. Drop a comment and let me know where you're watching from, what time it is, and whether you've ever really thought about your chin before tonight. I love reading these. People from Tokyo at 3 a.m. suddenly aware of their chins. London at dawn touching their faces. Los Angeles at midnight having an existential crisis about facial anatomy. It's beautiful. Let's start with the basics. What is a chin, exactly? Anatomically speaking, because it's not just the bottom of your face, it's not just where your jaw ends, it's something more specific, more peculiar. The chin is a bony protrusion at the front of the lower jaw, technically called the mental protuberance or mental eminence. Mental from the Latin mentum, meaning chin, not related to the mind, just the chin. It's formed by the mandible, your lower jawbone, which extends forward and slightly upward at the midline, creating that distinctive jutting shape. Now here's what's important. The chin isn't just thick bone. It's not just a robust jaw. Other animals have strong jaws, powerful mandibles, but they don't have chins. Because a chin is specifically an outward projection of bone beyond the teeth. If you look at a human skull from the side, you'll see the jaw extends forward past where the front teeth are. That forward extension, that extra bone sticking out, that's the chin. And no other animal has it. Chimpanzees have strong jaws, but if you look at a chimp skull, the jawbone slopes backward from the teeth. No projection. No protrusion, no chin. Gorillas have massive jaws, incredibly powerful, but again, no chin. The jaw is robust, but it doesn't extend forward. It recedes. Same with every other primate, every other mammal, every other vertebrate. Strong jaws, yes. Thick bone, yes. But no chin. No forward projection of the mandible beyond the teeth. Only humans have that. And it's been puzzling scientists since they first noticed it, which was surprisingly late. Because the chin is so obvious when you're looking at yourself, but when you're studying evolution, when you're comparing human anatomy to other animals, the chin stands out as an anomaly. a feature that doesn't make obvious sense. Early anatomists in the 1800s noted it, described it, cataloged it, but they didn't question it much. They just assumed it must serve some purpose, maybe structural, maybe functional. Surely evolution wouldn't create a feature for no reason. But as we learned more about evolution, as we discovered fossils of our ancestors, as we mapped out the human family tree, the chin became more mysterious, not less. Because we found that our ancestors didn't have chins. Not at first. Homo erectus, who lived 2 million years ago, no chin. Homo habilis, even earlier, no chin. And here's the really strange part. Neanderthals, our closest extinct relatives, didn't have chins either. We found hundreds of Neanderthal fossils, complete skulls, jawbones, and none of them have chins. The Neanderthal jaw is robust, thick, strong, but it recedes. It slopes backward. No forward projection, no mental protuberance, no chin. So Neanderthals, who were incredibly similar to us, who interbred with us, who shared 99.7% of our DNA, they didn't have the one facial feature that seems most obviously human. When did the chin appear? That's actually one of the few things we know with some certainty. The earliest clear evidence of chins appears around 200,000 years ago, in early Homo sapiens fossils. Not all of them, not at first. Early Homo sapiens had variable chins, some prominent, some weak, some barely there, but the feature was emerging. And by 100,000 years ago, most Homo sapiens fossils show clear chins. By 50,000 years ago, all of them do. Every modern human skull from the past 50,000 years has a chin, without exception. So the chin appeared sometime in the last 200,000 years, which means it's a recent development in evolutionary terms. For millions of years, our ancestors had no chins. Then suddenly, in the span of 100,000 years or so, chins became universal in our species. Why? What changed? What evolutionary pressure created the chin? That's the mystery. And to understand why it's such a mystery, we need to understand how evolution works. Evolution doesn't create features randomly. Every trait that becomes universal in a species must provide some advantage, or at least not provide a disadvantage. Traits that help you survive and reproduce get passed on. Traits that don't disappear. So, if chins became universal in humans, they must have served some purpose, right? But what purpose could a chin possibly serve? It's just extra bone sticking out of your face. It doesn't help you eat, doesn't help you breathe, doesn't help you fight. If anything, it seems like a liability, an extra thing to get hit, an extra thing to break. And yet, evolution created it, made it universal, made it one of the defining features of being human. There must be a reason, right? Or maybe not. Maybe the chin is a byproduct, a side effect of other changes, something that appeared not because it was useful, but because it came along with something else that was useful. This is one of the theories, and we'll explore it in depth. But first, let's look at all the theories, because scientists have proposed quite a few. Over the past 150 years, researchers have suggested that chins exist for mechanical strength, for sexual selection, for speech, for eating, or for no reason at all. Each theory has evidence, each theory has problems, and none of them explains everything. So we're left with a mystery, a feature that defines humanity, that separates us from every other animal, and we can't explain it. The chin enigma. Let's dive in. Theory number 1. The chin provides structural support. This is the oldest theory, and the most intuitive. The idea is that the chin strengthens the jaw. Think about it. The human jaw has to withstand a lot of force. When you bite, when you chew, you're putting hundreds of pounds of pressure on your teeth. And that pressure creates stress on the jawbone, particularly at the front, where the two halves of the mandible meet. This junction, called the symphysis, is a weak point, because it's where left and right come together. In most mammals, the symphysis is fused early in life. The two halves become one bone. In humans, the symphysis fuses in the first year of life, and according to the structural theory, the chin reinforces this weak point. The extra bone jutting forward distributes the stress of biting, makes the jaw stronger, less likely to fracture. This makes sense, intuitively, and early researchers thought it must be the answer. Humans evolved to eat tougher foods, or to use their teeth as tools, and the chin evolved to handle the stress. But there's a problem with this theory. Actually, several problems. First, humans don't have particularly strong bites compared to other primates. Chimpanzees can bite with more force than humans. Gorillas even more so, but they don't have chins. If the chin were for structural strength, you'd expect animals with stronger bites to have chins too, but they don't. Second, the human jaw has actually gotten weaker over time, not stronger. Our ancestors, like Homo erectus, had much more robust jaws than we do, thicker bone, bigger muscles, more chewing power, but no chins. Modern humans have thinner jaws, weaker chewing muscles, but we have chins. That's backwards. If chins were for strength, they should have appeared when jaws were getting stronger, not when they were getting weaker. Third, biomechanical studies show that the chin doesn't actually reinforce the jaw very effectively. Researchers have modeled the stress distribution in human jaws, used computer simulations to see where force concentrates when you bite, and the chin doesn't seem to help much. The stress patterns are about the same with or without a chin, so the structural theory doesn't hold up. The chin probably isn't there for mechanical strength. Which brings us to theory 2. The chin is for sexual selection. This theory suggests that chins became prominent not because they're useful, but because they're attractive. Sexual selection is a powerful force in evolution. Traits that make you more attractive to mates get passed on, even if they don't help you survive. Think of a peacock's tail. It's huge, colorful, impractical. Actually makes the peacock more vulnerable to predators. But peahens find it attractive, so males with bigger, brighter tails get more mating opportunities, and the trait spreads. Could the chin be like that? Could it be that humans with more prominent chins were considered more attractive? And so, the trait spread through sexual selection. There's some evidence for this. Studies show that people do judge attractiveness based on chin shape. A strong, well-defined chin is generally considered attractive, in both men and women, though the preferences vary by culture. In men, a strong chin is associated with masculinity, with strength, with dominance. In women, a more delicate chin is often preferred, but still defined, still present. So chin shape matters for attraction. But does that mean the chin evolved through sexual selection? Maybe. But there are problems with this theory too. First, if the chin were purely for attraction, you'd expect sexual dimorphism, meaning you'd expect men and women to have very different chins, like how peacocks have elaborate tails and peahens don't, or how male lions have manes and females don't. Sexual selection usually creates differences between sexes, but human chins aren't that different between men and women. Men tend to have slightly more prominent chins, slightly more angular, but the difference is subtle. Both sexes have chins. and they're broadly similar. Second, if chins were for sexual selection, you'd expect a lot of variation, because sexual selection often creates exaggerated, variable traits. Think of human height, or facial symmetry, or waist-to-hip ratio. These vary a lot between individuals, and that variation is partly because they're sexually selected traits. But chins don't vary that much. Sure, some people have strong chins, some have weak chins, but everyone has a chin. The basic structure is universal. That's more consistent with a functional trait than a sexually selected one. Third, we don't have evidence of sexual selection for chins in the fossil record. If chins were becoming more prominent because they were attractive, you'd expect to see a gradual increase in chin size over time, with individuals competing to have the biggest, most prominent chins. But that's not what we see. Chins appeared relatively suddenly, and once they appeared, they stayed pretty consistent. No exaggeration over time, no runaway selection. So the sexual selection theory is plausible, but not proven, and not entirely satisfying. Let's move to theory 3. The chin helps with speech. This is an interesting one. The idea is that the chin is related to the descended larynx and the changes in the vocal tract that make human speech possible. Remember, humans are unique in our ability to speak. We have a descended larynx, a flexible tongue, precise control over our lips and jaw. All of these are adaptations for speech, and some researchers think the chin might be part of that package. Here's the argument. Speech requires very precise control of the tongue. You need to move your tongue in specific ways to create different sounds, and the tongue is attached to the inside of the jaw, specifically to a structure called the genioglossus muscle. This muscle connects the tongue to the inner surface of the chin, and according to this theory, as the larynx descended, as the tongue became more flexible, as humans evolved the capacity for speech, the jaw had to change to accommodate these new structures. And the chin emerged as a result. It's an attachment point for the tongue muscles, an anchor that allows precise tongue control. This theory has some appeal, because the timing works. Chins appeared around the same time as evidence for complex language, around 200,000 to 100,000 years ago. And we know that speech is uniquely human, so maybe chins are too because they're linked to speech, but again, there are problems. First, the genioglossus muscle exists in other primates. Chimpanzees have it, gorillas have it. It attaches to their jaws too. But they don't have chins, so you don't need a chin for tongue attachment. Second, biomechanical studies show that the chin doesn't actually improve tongue control. The muscle attachments would work just fine without the forward projection. The chin doesn't provide better leverage, doesn't make the tongue more flexible, it's just there. Third, some early Homo sapiens had language but weak chins. And all modern humans have chins, even those who don't speak. So the correlation isn't perfect. The speech theory is interesting, but not conclusive. Theory 4. The chin is related to diet and chewing. Specifically, the idea is that as humans started cooking food, our jaws got smaller. Cooked food is softer, easier to chew. You don't need massive jaw muscles. You don't need thick bone. So over time, human jaws became more gracile, more delicate. And as the jaw shrank, other parts stayed the same size, or changed at different rates, creating the chin as a byproduct. Think of it this way. The jaw is made of multiple parts. The tooth row, the jaw body, the jaw angle. Each part can evolve independently. As the tooth row got smaller, As jaw muscles weakened, the front part of the jaw might have receded less than the rest, creating a relative projection, a chin. This is called the developmental byproduct theory, and it's currently the most popular explanation among scientists because it explains a lot. It explains why chins appeared when jaws were getting smaller. It explains why no other animal has chins, because no other animal went through the same reduction in jaw size. It explains why chins are universal, because the jaw reduction happened in all humans, and it doesn't require the chin to be useful. It's just a side effect, an accident of evolution. But even this theory has problems. First, it's hard to test, because we can't watch evolution happen. We can't see the jaw change over time in living humans. We can only look at fossils, and fossils don't tell us which parts of the jaw change first, or why. Second, other animals have experienced jaw reduction. Domesticated dogs, for example, have much smaller jaws than wolves, but they don't have chins. So jaw reduction alone doesn't create chins. Something else must be going on. Third, the byproduct theory feels unsatisfying because it essentially says the chin is meaningless, an accident, a quirk of development. And maybe that's true. Maybe the chin really doesn't mean anything, but it's such a prominent feature, such a defining characteristic of humanity. It seems like it should mean something, and that's where we are. Multiple theories, each with some evidence, each with some problems, and no definitive answer. We can't explain why humans have chins. We know when they appeared. Roughly 200,000 years ago. We know they're unique to humans. No other species has them. We know they're universal. Every human has one. But we don't know why. We don't know what evolutionary pressure created them. We don't know what function they serve, if any. The chin remains a mystery, an enigma hiding in plain sight, on your face, right now. If you're still awake, touch your chin again. Feel it. Think about how strange it is. This piece of bone, this projection, this uniquely human feature that we can't explain. Science has solved so many mysteries. We've mapped the human genome. We've sent probes to the edge of the solar system. We've split the atom, but we can't explain the chin. That's humbling. And beautiful, because it reminds us that there's still so much we don't understand. About ourselves, about our origins, about what makes us human. The chin is one of those things, a feature so obvious we never question it, until we do. And then it becomes profound. Sleep well, and dream of mysteries. The enigma continues. Good night. But let's not stop there, because there's so much more to explore about the chin, so many angles we haven't covered, so many fascinating details that reveal just how strange this feature really is. Let's talk about variation, because while every human has a chin, not all chins are the same. Some people have strong, prominent chins, jutting forward dramatically, like comic book superheroes. Others have weak chins, receding slightly, less pronounced. Some chins are pointed, others rounded. Some are wide, others narrow. Some people have cleft chins, that little dimple in the center. Others have smooth chins, no indentation. All of this variation is genetic. Your chin shape is determined largely by your DNA, inherited from your parents, just like your eye color or your height or your nose shape. And scientists have identified some of the genes involved. Not all of them, but some. Genome-wide association studies where researchers compare the DNA of thousands of people and look for correlations between genetic variants and physical traits have found several regions of the genome associated with chin shape. One of the most significant is near a gene called PAX3. This gene is involved in facial development. It helps determine how bones form in the embryo. Variants in or near PAX3 are associated with more prominent chins. Another gene, EDN1, also plays a role. EDN1 is involved in bone and cartilage development. Variants here affect chin width and projection. There are others too. Dozens of genes, probably hundreds, each contributing a small amount to the final shape of your chin. This is what geneticists call a polygenic trait, controlled by many genes, not just one, which is why chin shape varies so much between individuals, because everyone has a unique combination of these genetic variants, inherited randomly from their parents. But here's what's interesting. Despite all this variation, every human still has a chin. Even people with the weakest, most receding chins, they still have some forward projection of the mandible. Still have that mental protuberance. It's universal, which means whatever genes create the chin, they're present in all humans, fixed in our species. And that, again, suggests the chin appeared early in Homo sapiens evolution and spread to the entire population, either because it was advantageous or because it was neutral and just happened to be present in the population that survived. Now let's compare human chins to our closest relatives, because this really drives home how unique they are. Chimpanzees, our closest living relatives, don't have chins. If you look at a chimp skull, the mandible actually slopes backward from the teeth. There's no forward projection. In fact, there's a slight indentation, a concavity, the opposite of a chin. Gorillas are similar. Massive jaws, incredibly powerful, but no chin. The jaw recedes. Orangutans, same thing. Bonobos, same. Every primate, every ape, they all lack chins. But it's not just primates. No mammal has a chin. Dogs, cats, bears, elephants, whales, dolphins, none of them. No bird has a chin. No reptile, no fish. In the entire animal kingdom, across millions of species, across billions of years of evolution, only one species has ever developed a chin. Us, Homo sapiens. That's remarkable. That's not normal. Usually when a feature appears in evolution, it appears multiple times, in different lineages, through convergent evolution. Eyes, for example, they've evolved independently dozens of times, in vertebrates, in insects, in mollusks, because seeing is useful. So evolution finds ways to create eyes over and over. Wings are another example. Birds have wings. Bats have wings. Insects have wings. All evolved independently, because flight is useful. But chins? Only once. Only in humans, which suggest one of two things. Either the chin serves such a specific function that only humans needed it, or it serves no function at all and appeared by chance in our lineage. Both possibilities are strange. If it's functional, why so specific to humans? What are we doing that no other animal does that requires a chin? If it's not functional, how did it become universal? How did every human end up with one? The mystery deepens. Let's explore the fossil record in more detail, because the fossils tell us something important. They tell us that chins appeared gradually, not all at once. The earliest Homo sapiens fossils, from around 300,000 years ago, have very weak chins, barely any forward projection. You can see the beginnings of it, but it's subtle, not prominent. By 200,000 years ago, chins are more visible, more defined, still variable, but present. By 100,000 years ago, most Homo sapiens have clear chins, projecting forward, easily identifiable, and by 50,000 years ago, all of them do. So there was a transition period, a time when chins were emerging, becoming more prominent. This gradual appearance supports the byproduct theory, because if chins were under strong selection, if they provided a major advantage, you'd expect them to appear suddenly, all or nothing. But instead, they appeared gradually, as jaws got smaller, as faces became more vertical, as other changes happened in the skull. The chin emerged as a consequence, or at least that's what the fossils suggest. But there's another piece of evidence we need to consider: Neanderthals. Our extinct cousins. Neanderthals and Homo sapiens shared a common ancestor around 600,000 years ago. We diverged, evolved separately. Neanderthals in Europe and Western Asia, Homo sapiens in Africa. And then, around 50,000 years ago, we met again, and interbred. Today, most non-African humans have about 1 to 2% Neanderthal DNA, so we're related very closely. But Neanderthals didn't have chins. We've examined dozens of Neanderthal skulls, complete mandibles, and none of them show a chin. The jaw is robust, thick, strong, but it recedes, slopes backward, no forward projection. This is significant because it tells us that the chin evolved specifically in the Homo sapiens lineage. After we split from Neanderthals, it's not something we inherited from a common ancestor. It's something new, unique to our branch of the family tree. And that raises a question. Did the chin give Homo sapiens an advantage over Neanderthals? Is that why we survived and they didn't? Probably not, because the chin doesn't seem to do anything important. And Neanderthals were incredibly successful for hundreds of thousands of years. They survived ice ages. They hunted massive animals. They made sophisticated tools. They buried their dead. They created art, all without chins. So the chin wasn't necessary for success. Neanderthals proved that. But still, it's interesting. We have chins, they didn't. We survived, they didn't. Is there a connection? Most scientists think no. The extinction of Neanderthals was due to other factors: climate change, competition with Homo sapiens, possibly disease. Not the lack of chins, but the correlation is there, and it's worth noting. Now let's shift to a different angle. Cultural perceptions of chins. Because humans don't just have chins. We judge people by their chins. We assign meaning to chin shape. In many cultures, a strong chin is associated with strength, with confidence, with leadership. Look at depictions of heroes and leaders throughout history. In art, in sculpture, in comics and movies, they almost always have strong, prominent chins. Superman has a massive chin. Batman, same. Captain America, same. Every action hero in Hollywood seems to have been cast based partially on chin prominence. It conveys masculinity, power, authority. On the other hand, a weak or receding chin is often seen as a sign of weakness, of timidity, of being less capable. Villains and sidekicks in fiction often have weak chins. It's a visual shorthand, a way to signal to the audience who's dominant and who's not. This is unfair, of course. Chin shape has nothing to do with actual personality, nothing to do with capability. It's just bone structure. But the association is deep, and it exists across many cultures. Studies have shown that people make judgments about others based on chin shape. In experiments where people are shown photos of faces and asked to rate them on various traits, faces with stronger chins are rated as more dominant, more trustworthy, more competent. Even though there's no rational reason for this. It's just a bias we have, an unconscious association. And it affects real decisions. There's evidence that people with stronger chins are more likely to be hired for leadership positions, more likely to be elected to political office. Not because they're more capable, but because they look more capable, because of their chins. This is called the facial dominance effect, and it's well documented, so chins matter, socially, culturally, even if they don't matter functionally. And this has led to a whole industry: chin augmentation, plastic surgery to change chin shape, make it more prominent, more defined. Thousands of people every year get chin implants, or chin reduction, or chin reshaping, because they're unhappy with the chin they were born with, because they want to change how they're perceived. And cosmetic surgeons oblige. They can add bone, remove bone, reshape the mandible, create whatever chin shape the patient wants. It's a common procedure, relatively simple, and it can dramatically change a person's appearance, their profile, how they look from the side. So chins, this mysterious evolutionary feature, have become a matter of aesthetics, of self-image, of social perception. We can't explain why they exist, but we care deeply about how they look. That's very human. Let's talk about development, how chins form in the womb, because this might give us clues about why they exist. When a human embryo is developing, the face forms from several separate pieces. These pieces, called facial prominences, grow and fuse together to create the final facial structure. The lower jaw, the mandible, forms from two separate halves, left and right. These halves start as cartilage, then ossify, turn into bone, around the 7th week of development, and they fuse together at the midline. At the symphysis, this fusion creates the chin region. But here's what's interesting. The chin doesn't appear immediately. In the fetus, the jaw looks more like a chimpanzee jaw, receding, no forward projection. The chin develops later, after birth, during childhood. As the jaw grows, the front part of the mandible grows forward more than the rest, creating that projection, that mental protuberance. By adolescence, the chin is fully formed, and it stays that way for life. Well, mostly. Chins can change slightly with age. They can become more prominent as the face loses soft tissue, or less prominent if weight is gained and fat accumulates under the chin. But the basic bone structure doesn't change much. So what controls this growth? What tells the front of the jaw to grow forward? Genes, obviously. But which genes? And how, we don't fully know, but we know it involves complex interactions between multiple genes and environmental factors, like nutrition, like mechanical stress from chewing. All of this affects how the jaw develops, and minor variations in any of these factors can lead to different chin shapes. This is why identical twins who share the same DNA can have slightly different chins. Because development isn't purely genetic, it's also environmental and stochastic, random. So your chin is the result of genes, environment, and chance, a combination of factors coming together during development to create the unique shape you ended up with. And that shape, once formed, becomes part of your identity, part of how you see yourself, and how others see you. All because of a piece of bone that serves no obvious function. It's fascinating and strange. Let's examine some alternative theories that have been proposed over the years, because scientists haven't just suggested the 4 main theories we discussed. There have been others, some more plausible than others. Theory 5. The chin is a side effect of brain expansion. This theory suggests that as human brains got bigger, the skull had to change to accommodate the larger brain. the face became more vertical, more tucked under the brain case, and this reorientation of the face created the chin as a byproduct. It's an interesting idea, and there's some evidence for it. Human faces are more vertical than other primates. We don't have protruding snouts. Our faces are flat, tucked under our large skulls. And this vertical face might have required the jaw to project forward to maintain proper bite alignment. But there are problems with this theory. Neanderthals had brains as large as, or larger than, modern humans, and they didn't have chins, so brain size alone doesn't explain it. Theory 6. The chin is related to running. This is a weird one, but some researchers have suggested that the chin might help stabilize the head during long-distance running. Humans are unusual among primates in our ability to run long distances. We're endurance runners, and running creates a lot of impact, a lot of jostling. The head moves up and down, and maybe the chin helps absorb some of that impact, helps stabilize the jaw. But this theory has very little support. There's no biomechanical evidence that the chin affects running performance, and other endurance runners like dogs or horses don't have chins, so it's probably not related to running. Theory 7. The chin is for social display. Not sexual selection, but social signaling more broadly. The idea here is that chins make faces more expressive, more variable, and humans are highly social. We rely on facial expressions to communicate, to signal emotions, to build relationships. Maybe the chin adds to that, makes our faces more distinctive, more recognizable, easier to read. It's a plausible idea, but again hard to test, and it doesn't explain why chins are universal. If they were for social display, you'd expect more variation, more diversity in chin shapes. So this theory, like the others, is suggestive but not conclusive, which brings us back to where we started. We don't know. Despite decades of research, despite all the theories, despite all the fossils and genetic studies and biomechanical models, we still can't explain the chin. It's one of those scientific mysteries that resists easy answers, and maybe that's okay. Maybe not. Everything needs an explanation. Maybe some things just are. The chin exists. It's uniquely human. It's universal, and it's mysterious. And that mystery is part of what makes us human. Because humans are the species that asks why, that looks at ourselves and wonders about our origins, about our nature, about the strange features we carry. No other animal does that. No other animal contemplates its own chin, but we do. And maybe that's more important than knowing the answer. The ability to ask the question, to be curious, to wonder, that's what defines us. And the chin, in its mysterious existence, reminds us of that. Reminds us that we're still discovering who we are, still learning about ourselves, still finding new mysteries to explore. Sleep well, and when you wake, touch your chin again. Feel that strange protrusion, that uniquely human feature, and remember that you're part of a mystery, a living enigma, the only species in the history of life on Earth to have a chin, and we still don't know why. Good night. There's more we need to explore, because the chin mystery goes deeper than we've discussed so far. Let's talk about what makes the human face unique overall, because the chin isn't the only strange thing about our faces. It's part of a whole package of unusual features. Human faces are flat compared to other primates. We don't have protruding snouts. Our noses stick out, but our jaws don't. Our faces are tucked under our large skulls. This is called facial retraction, and it's unique to humans. Chimpanzees have protruding faces. Their jaws jut forward. Their noses are flat against their faces. They have a snout, basically. Gorillas even more so. Huge faces, massive jaws. But humans? Flat, vertical, retracted. Why? It's related to our large brains. As the human brain expanded, the skull grew. The brain case got bigger, and to accommodate that larger brain case, the face had to reposition. It moved underneath the skull, became more vertical, less protruding. This happened gradually over millions of years. Early hominins like Australopithecus had protruding faces. Like apes, Homo erectus had less protruding faces, more vertical, but still not as flat as modern humans. And Homo sapiens has the flattest face of all, the most vertical, the most retracted, and the chin appeared as part of this process. As the face became flatter, as the jaw receded, the front part of the mandible somehow didn't recede as much, or it grew forward for some reason, creating the chin. So the chin might be a consequence of our unique facial geometry, a byproduct of having a large brain and a flat face. This ties into the developmental byproduct theory, but it adds another layer. It's not just about jaw reduction. It's about the entire reorganization of the skull, the chin, as part of a larger package of changes. And this makes sense, because evolution doesn't change one feature at a time. It changes systems. The skull is a system. The brain, the face, the jaw, all connected, all developing together, all evolving together. Change one part and the others adjust. The chin might be one of those adjustments, a consequence of other, more important changes. Not important in itself, but important as part of the overall package. This is a more nuanced view, and it's probably closer to the truth than any single, simple explanation. Now let's talk about what the chin tells us about human uniqueness, because the chin is just one of many features that separate us from other animals. We have large brains. We walk upright. We have language. We use complex tools. We create art. We have culture. All of these are unique or nearly unique to humans, and they all evolved together in a package. The chin is part of that package. It's not the most important part. Not even close. But it's a visible marker, a sign that we're different, that we've taken a unique path in evolution. When you look at a human face, you see a chin. And that chin, more than almost anything else, tells you immediately, this is a human. Not a chimp, not a gorilla. A human. That's powerful. A simple piece of bone conveying species identity. And it's probably why we care so much about chin shape. Why we judge people by their chins. Because subconsciously we recognize that chins are about being human. About belonging to our species. And a strong chin signals, this person is really human. Really one of us. Of course, that's not true. Everyone with a chin is equally human. Chin shape doesn't determine humanity. But the association is there, deep in our brains. A cognitive shortcut, a bias. An understanding that bias helps us understand ourselves, helps us see how we think about identity, about belonging, about what makes us us. Let's shift to a practical question. Do chins serve any function in modern life? Do they do anything useful? The answer is probably no. You can live a perfectly normal life without a prominent chin. People with receding chins, people with weak chins, they function just fine. The chin doesn't help you eat, doesn't help you speak, doesn't help you breathe. It's just there. But that doesn't mean it doesn't matter, because in our social world, appearance matters. How you look affects how people treat you. And chin shape is part of appearance. We've already discussed how strong chins are associated with leadership, with competence, with attractiveness. These associations affect real outcomes: who gets hired, who gets promoted, who gets elected, who is considered attractive. So in that sense, chins matter, not functionally, but socially. And that's why people get chin surgery, why they spend thousands of dollars to change their chin shape. Because they believe it will improve their lives, will make them more successful, more attractive, more confident. Does it work? Sometimes. Changing your appearance can change how you feel about yourself, can boost confidence, and confidence affects how you interact with others. So maybe it does help. Indirectly, not because the chin itself does anything, but because changing it changes your self-perception. And that changes your life. It's a feedback loop. Social perceptions affect individual choices. Individual choices affect social perceptions. And the chin, this mysterious piece of bone, is caught in the middle. Now let's talk about evolutionary spandrels, because this concept is central to understanding the chin. Stephen Jay Gould, the famous paleontologist, introduced the concept of spandrels to evolutionary biology. The term comes from architecture. A spandrel is the triangular space that appears between an arch and a rectangular frame. It's not designed, it's not functional, it's just a byproduct of the arch and frame existing together. But once the spandrel exists, architects often decorate it, use it for art, give it purpose. In evolution, a spandrel is a feature that wasn't selected for directly. It appeared as a byproduct of other features, but once it existed, it might have been co-opted for a new function. Or it might just remain a byproduct. The chin might be a spandrel. It appeared as a byproduct of facial retraction, of jaw reduction, of the reorganization of the skull. Not because it was useful, but because it was an inevitable consequence of other changes. And once it appeared, maybe it was co-opted. Maybe it became useful for something. Sexual selection, social signaling. We don't know. Or maybe it was never co-opted. Maybe it just stayed a spandrel, a feature with no function, just there because of the way the skull developed. This is unsatisfying to some people, because we want every feature to mean something, to serve a purpose. But evolution doesn't work that way. Not everything is adaptive. Not everything has a reason. Some things just are. And the chin might be one of those things. A beautiful, mysterious spandrel. Let's explore the psychology of the chin, how we perceive chins, what they mean to us. Research shows that people form impressions of others based on facial features in milliseconds. Before they're even conscious of it, the brain processes faces automatically, extracts information about age, sex, emotion, identity, and one of the features it processes is the chin. Chin shape affects perception of dominance, trustworthiness, attractiveness, competence. People with strong, prominent chins are perceived as more dominant, more masculine in men, more confident, more capable. People with weak or receding chins are perceived as less dominant, less confident, sometimes less trustworthy. These perceptions are automatic, unconscious, and largely universal across cultures. Why? No one knows for sure. It might be evolutionary. Maybe in our ancestral past, chin shape correlated with some actual trait, like testosterone levels, or health, and so we evolved to pay attention to it. Or it might be cultural, learned associations passed down through generations, strong chins in heroes, weak chins in villains, media reinforcing stereotypes, creating associations that become ingrained. Or it might be both, a combination of evolved biases and cultural learning. Either way, the associations are real, and they affect how we interact with each other. Studies have shown that politicians with stronger chins are more likely to win elections. CEOs with stronger chins are rated as more effective by their boards. Actors with strong chins are more likely to be cast as leaders or heroes. It's a subtle effect. Not the only factor, but it's there. Measurable. Real. So chins, while serving no obvious biological function, serve a social function. They signal status, dominance, capability, whether accurately or not, and that signal affects outcomes. Now let's consider individual variation more deeply, because not all chins are the same. Some people have cleft chins, that little dimple or groove down the center. This is caused by incomplete fusion of the two halves of the mandible. During development, the left and right sides don't quite meet perfectly, leaving a small gap, which appears as a cleft. Cleft chins are genetic, inherited, and they're more common in some populations than others. Europeans tend to have higher rates of cleft chins than Asians or Africans. Though it exists in all populations, some people find cleft chins attractive, others don't. It's a matter of personal preference. But like chin size, cleft chins affect perception. They make a face more distinctive, more memorable, and in some contexts, that's an advantage. Then there's chin width. Some people have wide chins, square, broad. Others have narrow chins, pointed, delicate. This too is genetic, controlled by multiple genes, and it correlates with other facial features. People with wider jaws tend to have wider chins. People with narrower jaws, narrower chins. It's all part of the overall facial architecture. Chin projection also varies. Some people's chins jut forward dramatically, others recede slightly. Again, genetic. Again, affecting perception. Forward projection is associated with dominance, masculinity, in men. Less projection with femininity, youthfulness in general. But these are just tendencies, averages. Individual variation is huge, and there's no right chin shape. No optimal form, just variation, diversity, the result of millions of years of evolution and thousands of generations of genetic mixing, creating the incredible variety of chins we see today. All human, all unique. Let's talk about chins in art and media, because artists have long been aware of the significance of the chin. In classical sculpture, Greek and Roman artists emphasized strong chins in their depictions of gods and heroes. Zeus, Apollo, Hercules, all portrayed with prominent, well-defined chins. It was part of the ideal of male beauty, strength, nobility, divine perfection. In Renaissance art, the same. Michelangelo's David has a strong, prominent chin, a sign of his heroism, his capability. In modern media, the tradition continues. Superman, created in 1938, was given a massive square chin. So was Batman. Captain America. Every superhero seems to have been designed with chin prominence in mind, because it signals strength, power, heroism. On the other hand, villains and sidekicks often have weak or receding chins, or unusual chin shapes. Think of cartoon villains. They often have pointed chins, or no chins at all. It's a visual shorthand, a way to signal to the audience, this character is not the hero. This is conscious design. Artists know that facial features convey meaning, that chins matter, and they use that knowledge to create characters that communicate instantly. Before you even hear them speak, you know who they are based on their chin. It's powerful, and it shapes our perceptions, because we internalize these associations, We see them over and over in media, and they become part of how we think. Strong chin equals hero, weak chin equals not hero. It's reductive. It's unfair. But it's how visual storytelling works, and it affects how we perceive real people, whether we realize it or not. Now let's shift to a completely different angle. The chin in language and metaphor. We use chin-related expressions all the time. Keep your chin up, meaning stay positive, don't get discouraged. The image is of someone who's defeated, head down, chin dropped. Keeping your chin up means maintaining dignity, maintaining hope. Take it on the chin, meaning accept defeat or criticism gracefully. The image is of being punched in the chin but not falling down, standing your ground. These metaphors are interesting. They connect the chin with resilience, with strength, with dignity. In English, anyway. Other languages have different chin-related expressions. In Chinese, there's an expression that translates roughly to "chin becomes long," meaning someone is embarrassed or ashamed. Their chin droops. In French, faire la gueule includes reference to jutting the lower jaw forward in a pout or sulk. So across cultures, the chin is associated with emotion, with expression, with communication. Even though anatomically the chin doesn't move much, it's the jaw that moves. The chin just goes along for the ride, but we focus on it, we notice it, and we use it as a reference point for understanding what someone's feeling, whether they're strong or weak, happy or sad, confident or defeated. The chin becomes meaningful through association, through metaphor, through culture, even if biologically it's just bone. Let's talk about what happens when chins are damaged, because this can tell us something about their role. If you break your jaw, if you fracture the mandible, it can heal, but it can also affect the chin. Depending on where the fracture is, if it's at the symphysis where the two halves meet, the chin can shift, become asymmetric, or recede. This affects appearance, but does it affect function? Generally, no. As long as the jaw still aligns properly, as long as you can bite and chew, the shape of the chin doesn't matter functionally. You can eat, you can speak, you can live normally. The damage is cosmetic, not functional. This supports the idea that the chin doesn't serve a critical function, because you can lose it or damage it and still be fine. Contrast this with other facial features. If you damage your nose, it affects breathing. If you damage your teeth, it affects eating. If you damage your eyes, it affects vision. But the chin, it's optional. Functionally speaking, which again suggests it's not there for a critical reason. It's just there. A feature that happened to evolve, and once it existed, we assigned it meaning, social meaning, cultural meaning, but not biological meaning. Now let's explore what the future might hold. For chins, are they evolving, changing, or are they staying the same? It's hard to say, because evolution is slow. Changes take thousands of years to become visible. But we can look at trends. Is the human jaw continuing to shrink? Some evidence suggests yes. Modern humans have smaller jaws than humans from a few thousand years ago. This is partly because of diet. We eat softer food, cooked food, processed food. We don't need powerful jaws to chew tough meat or fibrous plants. So our jaws have gotten smaller, weaker, and this might continue. If it does, what happens to the chin? Does it get more prominent as the jaw recedes further, or does it recede too? We don't know. It depends on how the different parts of the jaw change. If the front part stays the same while the rest shrinks, chins get more prominent. If everything shrinks proportionally, chins stay the same, or get smaller. We won't know for thousands of years, but it's interesting to think about. Another factor is sexual selection. If chin shape continues to affect mate choice, it will continue to evolve. But modern mate choice is complicated. It's not just about physical features anymore. It's about personality, education, wealth, shared interests. Physical appearance matters, but it's not the only thing. So sexual selection might be weaker now than in the past, which could mean chin shape is under less pressure to change. Then there's technology. Plastic surgery allows people to change their chin shape. If this becomes common, if many people alter their chins, does it affect evolution? Not really. Because surgical changes aren't genetic. They don't get passed to offspring. Your natural chin shape is what gets inherited, not your surgically altered one. So plastic surgery doesn't change evolution directly. But it might change sexual selection. If people with weak chins get surgery, they might become more attractive, get more mating opportunities, and pass on their weak chin genes. This could counteract natural selection against weak chins. If there ever was such selection, it's complicated, and we're only just beginning to understand how modern technology interacts with evolution. But one thing is clear: the chin is here to stay, at least for the foreseeable future. It's a fixed feature of Homo sapiens, part of what defines us, and unless something dramatic happens, humans will continue to have chins for millennia to come. Let's return to the question of meaning. What does the chin mean? What does it tell us about being human? On one level, it tells us that evolution is messy. Not everything that evolves has a clear purpose. Some things just happen. As byproducts, as accidents, and then they persist. Because they're not harmful enough to be selected against. The chin might be one of those things. A happy accident, a quirk of our evolutionary history. On another level, the chin tells us that humans are obsessed with meaning. We can't just accept that something exists. We need to know why. We need it to mean something. So we've assigned meaning to the chin, made it a symbol of strength, of character, of identity. Even though it's just bone, this is very human. This need to create meaning, to find patterns, to explain the world. And the chin, in its mysterious existence, invites that, invites us to wonder, to speculate, to theorize. And maybe that's its real purpose. Not biological, but philosophical. The chin exists to make us think, to make us question, to remind us that we don't know everything, that there are still mysteries right in front of us, on our faces. And that's beautiful. That's profound, because it means there's always more to discover, always more to learn, even about ourselves, even about the most basic, obvious features of our own bodies. The chin is a reminder that science is never finished, that knowledge is always incomplete, that mysteries remain, and that's exciting. That's what keeps us curious, keeps us exploring, keeps us human. Before we end, let's consider one more thing: the emotional connection people have to their chins. Because for something that serves no obvious function, people care a lot about their chins. They obsess over them, worry about them. Some people are self-conscious about their chin shape, feel like it defines them, limits them. They avoid photos from certain angles, hide their chins with their hands. Consider surgery. Others are proud of their chins, see them as a mark of beauty, of strength, of family heritage. I have my father's chin. I have my grandmother's chin. It becomes part of identity, part of how you see yourself, and that emotional connection is real. It affects self-esteem, affects confidence, affects how you move through the world. So even though the chin doesn't do anything, it matters psychologically, emotionally, socially, and that's worth acknowledging, worth respecting, because humans are not purely rational beings. We're emotional, social, symbolic, and features like the chin, even if they're functionally meaningless, can carry enormous meaning in our lives. So if you're someone who worries about your chin, know that you're not alone. Know that it's normal to care about appearance, but also know that your chin, whatever shape it is just bone. It doesn't define your worth, doesn't define your capability, doesn't define who you are. It's just a feature, a unique, mysterious human feature, and it's part of what makes you you. Sleep well, dream of chins, of mysteries, of the strange and wonderful features that make us human. The enigma continues, and tomorrow, when you wake, when you look in the mirror, when you see your chin staring back at you, remember this: you're looking at a mystery, a feature unique to your species, found nowhere else in nature, present for 200,000 years, and still unexplained. Scientists have theories, but no answers. The chin remains an enigma, a beautiful, visible, tangible enigma on your face right now. Touch it one last time. Feel that bone, that protrusion, and marvel at the fact that after all our science, all our knowledge, all our technological advancement, we still can't explain it. We can't explain the chin, and maybe we never will. Maybe it will remain a mystery forever, a reminder of how much we don't know, how much wonder still exists in the world, even in the mirror, even on your face. Good night. Sweet dreams. The chin enigma endures forever. One more exploration before sleep takes you completely. Let's dive into the comparative anatomy of the chin across different human populations. Because while all humans have chins, chin morphology varies between ethnic groups, between populations, between geographic regions. Studies have shown that Europeans tend to have more prominent chins on average than Asians. Africans fall somewhere in between. But these are just averages. There's enormous variation within each group, much more variation within populations than between them, which is true of most human traits. We're more similar than different. But the differences exist, and they're interesting. Why do they exist? Partly genetics. Different populations have different frequencies of chin-related genetic variants through genetic drift, random changes in gene frequencies over time, or through founder effects. When small groups migrate to new regions, they carry only a subset of the original population's genetic variation, and that subset might happen to include genes for more or less prominent chins. Partly environment. Diet affects jaw development. Populations that historically ate tougher foods might have developed larger, more robust jaws, and as a byproduct, different chin shapes. Partly sexual selection. If different cultures have different beauty standards, different ideas about what makes a chin attractive, then sexual selection would push chin shape in different directions, in different populations. All of these factors interact, creating the variation we see today. But again, it's important to emphasize that every human has a chin. The variation is in shape, size, prominence, not in presence or absence. The chin is universal. And that universality is what makes it so significant. Let's talk about chin shape and personality, because there's a long history of people trying to read personality from facial features. This was called physiognomy, and it was very popular in the 18th and 19th centuries. The idea was that your face reveals your character, your inner nature. A strong chin meant you were determined, strong-willed, capable, A weak chin meant you were timid, indecisive, weak. A jutting chin meant you were aggressive. A receding chin meant you were submissive, and so on. This was taken very seriously, used in criminal investigations, in hiring decisions, in matchmaking. People believed you could judge someone's worth by their face. We now know this is nonsense. Complete pseudoscience. Facial features don't determine personality. They're not connected. You can have a weak chin and be incredibly strong-willed. You can have a strong chin and be timid. There's no correlation. But the belief persists, unconsciously. We still make judgments based on facial features, even though we know better, even though we know it's unfair. The associations are too deep, too automatic, too ingrained by culture and evolution. So we continue to judge people by their chins, and people continue to be affected by those judgments. It's a cycle that's hard to break. Awareness helps. Knowing that chin shape is just genetics, just development, just randomness, but awareness isn't enough to override unconscious biases. Those run deeper, and they affect us whether we want them to or not. Let's explore the chin in different cultures' beauty standards. Because what's considered attractive varies widely. In Western culture, particularly in North America and Europe, a strong, prominent chin is generally considered attractive in men. It's associated with masculinity, with strength, but not too prominent. There's a balance. Too much and it becomes odd. In women, preferences are more varied. Some prefer a delicate, less prominent chin. Others prefer a more defined chin. It depends on overall facial harmony. In East Asian cultures, preferences are different. A more delicate, smaller chin is often preferred in both men and women. A V-shaped face with a pointed chin is considered very attractive in countries like South Korea. So much so that chin reduction surgery is very popular. People get their chins shaved down, made smaller, more pointed, to conform to the cultural ideal. In other cultures, chin shape matters less. Other features are more important. Eyes, nose, lips, skin. The chin is just one part of the whole. These cultural differences show that chin beauty is constructed, not innate. What's attractive is learned, culturally specific, variable, which makes the obsession with chin shape even more interesting. Because if it were purely biological, purely about fitness or health or genes, you'd expect universal preferences. But you don't get that. You get variation, which suggests chin preferences are cultural, learned, malleable, and yet they still affect people profoundly, still drive people to surgery, still influence social outcomes. Cultural doesn't mean unimportant, it means socially constructed. But social constructions have real power. Now let's shift to the mechanics of chin surgery, because this is actually fascinating. And it reveals a lot about how we think about the chin. There are two main types of chin surgery: genioplasty and chin implants. Genioplasty is the more invasive option. The surgeon actually cuts the mandible, the front part of the jawbone, and repositions it, slides it forward to make the chin more prominent, or backward to make it less prominent, then fixes it in place with plates and screws. The bone heals in its new position, and you have a new chin shape, permanently. Chin implants are less invasive. The surgeon inserts a silicone or plastic implant over the existing chin bone, augmenting it, making it more prominent. This doesn't change the underlying bone, just adds to it. It's reversible. You can remove the implant if you change your mind. Both procedures are common. Both have risks: infection, implant shifting, nerve damage. but they're generally safe, and they work. They change how you look, how your profile appears, and for many people that change is worth the risk, worth the cost, worth the recovery time, because they believe it will improve their lives. Does it? For some, yes. Changing your appearance can boost confidence, can change how you feel about yourself, and that can have cascading effects. More confidence means better social interactions, better job performance, better relationships. So indirectly, chin surgery can improve your life. For others, no. The surgery doesn't solve deeper issues, doesn't change who you are inside, and the disappointment can be profound. It's a gamble, and one that reveals how much power we give to appearance, how much we believe that changing how we look will change how we feel. Sometimes it's true, sometimes it's not. But the belief drives billions of dollars in cosmetic surgery every year. And the chin, this functionally useless piece of bone, is part of that industry. Now let's talk about the chin and aging, because chins change as we get older, not the bone itself. That stays relatively stable, but the soft tissue around it. As we age, we lose fat in the face. Skin loses elasticity, sags, and this affects how the chin looks. Some people develop a double chin. Fat accumulates under the chin, between the chin and the neck, creating a second fold. This can happen at any age as you gain weight, but it's more common as you get older, because metabolism slows. Fat distribution changes. Others develop a turkey neck, sagging skin under the chin, hanging loose. This is purely aging. Loss of collagen, loss of skin tone, gravity pulling everything down. Both of these affect how the chin appears, can make a once prominent chin look weak, can obscure the jawline, can change your profile dramatically. And because we associate chin prominence with youth and vitality, these changes can be distressing, can make people feel old, unattractive, past their prime. This has led to another branch of cosmetic procedures: neck lifts, liposuction under the chin, skin tightening, all designed to restore the youthful chin and jawline, to fight aging, to maintain the appearance of vitality. Again, the chin becomes a battleground, a site where we struggle against time, against nature, against the inevitable changes that come with aging. It's poignant, and it reveals how much we care about appearance, how much we fear aging, how much we want to control how we look, even when we know it's futile, even when we know aging is natural, inevitable, universal. We still fight it. And the chin is one of the fronts in that battle. Let's return to evolution one more time, because there's an interesting question we haven't fully explored. Could the chin have evolved through random genetic drift? Genetic drift is evolution by chance, not by selection. In small populations, gene frequencies can change randomly from generation to generation, just by chance. Who happens to reproduce? Who happens to die? Over time, this can lead to fixation, where one genetic variant becomes universal in a population, not because it's better, just because it got lucky. Could this have happened with the chin? Maybe. If early Homo sapiens went through a population bottleneck, a time when numbers were very low, genetic drift would be powerful, and if the survivors happened to carry genes for a prominent chin, those genes would spread, become universal. Not because chins were useful, just because that's who survived. This is a plausible scenario. We know Homo sapiens went through at least one severe bottleneck around 70,000 years ago after the Toba supervolcano eruption. Human populations crashed. maybe down to just a few thousand individuals, and then rebounded. If those survivors had chins, and the populations that didn't survive didn't, then chins would become universal, through drift, through chance, through the randomness of survival. This is the most nihilistic explanation. The chin means nothing. It's just an accident, a random outcome of a random process, but it's also the most parsimonious, the simplest. It doesn't require selection, doesn't require function, doesn't require purpose, just chance. And evolution is full of chance, full of accidents that become permanent features. The chin might be one of them, and if that's true, it's beautiful in its own way, because it means we're carrying the legacy of a random event, a lottery that determined who survived and who didn't, and the winners happen to have chins, so now we all do. It's a reminder of how contingent existence is, how easily things could have been different. If different people had survived Toba, maybe humans wouldn't have chins, maybe we'd look completely different, but they didn't. And we do, and here we are. Let's end with a reflection on what this mystery means. The chin mystery. The fact that we can't explain it. What does that tell us? It tells us that science has limits. We can't know everything, can't explain everything. Some questions are too hard. Some evidence is too sparse. Some events happened too long ago to reconstruct, and that's okay. That's part of science, knowing what you don't know, being honest about uncertainty, not pretending to have answers you don't have. The chin mystery is a perfect example. We have theories, good theories, plausible theories, but no definitive answer, and we might never have one, because the evidence we'd need doesn't exist. We can't go back in time, can't watch evolution happen, can't ask our ancestors why their chins developed. All we can do is speculate, make educated guesses, test what we can test, and accept that some mysteries remain mysteries. And that's beautiful, because it keeps us humble, keeps us curious, keeps us searching. If we knew everything, if every question had an answer, what would be the point? Where would the wonder be? The mystery is the point, the not knowing, the searching, the questioning. And the chin, this simple piece of bone, this everyday feature embodies that. It's a mystery we live with, literally, on our faces, every day. And it reminds us that the world is still full of wonders, still full of unknowns, still full of questions waiting to be asked. So as you drift off to sleep, as you let go of consciousness, let the chin mystery settle into your mind. Let it become part of how you see yourself. You're not just a person with a chin. You're a mystery, a walking, talking, breathing mystery. Part of a species that evolved a feature no other species has. For reasons we still don't understand. That's profound. That's amazing. That's worth marveling at. Even as you fall asleep. Good night, sweet dreams, and may you wake tomorrow with a new appreciation for the mystery on your face, the chin that defines you as human, the feature we can't explain, the enigma that endures forever. Let's go even deeper, because there are still angles we haven't fully explored, fascinating details about chins that illuminate this mystery from new perspectives. Let's talk about chin development in infancy and childhood, because chins don't just appear fully formed at birth. When a baby is born, their face is very different from an adult's. Their chin is almost non-existent, receding. The jaw is small. The face is round. This is normal. This is how all babies look, because the jaw hasn't finished growing. As the child develops, as they start eating solid foods, as they chew and talk, the jaw grows, develops, strengthens, and the chin emerges. By age 5 or 6, most children have a visible chin. By adolescence, it's fully developed. The same size and shape it will be for life, unless altered by surgery or affected by injury. This developmental pattern is interesting because it suggests the chin is responsive to mechanical stress, to the forces of chewing and speaking. Children who chew more, who eat tougher foods, might develop stronger jaws, more prominent chins. Children who eat only soft processed foods might develop weaker jaws, less prominent chins. This is one explanation for why modern humans have smaller jaws on average than our ancestors. We eat softer food, put less stress on our jaws during development, and so they develop less robustly. But does this affect the chin specifically? Or just the jaw overall? We don't know for sure, but it's plausible that diet during childhood affects final chin shape, even though genetics is the primary factor. Now let's explore the chin's role in facial recognition. Because humans are incredibly good at recognizing faces, we can distinguish thousands of individual faces, remember them for years, identify people from just a quick glance. This is a specialized cognitive ability, supported by dedicated brain regions, the fusiform face area, the superior temporal sulcus. These areas process facial features automatically, rapidly, creating a mental representation of each unique face, and the chin is part of that representation. Studies using face morphing and manipulation have shown that changing chin shape affects how recognizable a face is. The chin contributes to the overall gestalt of the face, the unique configuration of features that makes each person distinct. So even though the chin doesn't move, doesn't express emotion, doesn't do much functionally, it serves as an identifier, a landmark, part of what makes your face yours. This might be one reason why chin shape is genetically controlled, why it's heritable, because being recognizable is important, helps with social bonding, helps others remember you, trust you, interact with you consistently. And the chin, as a stable, visible feature, aids in that recognition. It's an interesting perspective. The chin is a social tool, not for communication directly, but for identity, for being known, for being a distinct individual. Let's shift to mythology and folklore, because cultures have long assigned meaning to physical features, and the chin appears in many traditional beliefs. In some cultures, a prominent chin was seen as a sign of noble birth, of aristocratic lineage. Kings and queens were depicted with strong chins, peasants with weak ones. This was purely social construction, a way to justify hierarchy, but it shows how deeply the chin was associated with status, with power. In Chinese face reading called physiognomy or mian xiang, the chin represents old age and legacy. A well-formed chin suggests a comfortable old age, many descendants, a lasting impact. A weak or receding chin suggests loneliness in old age, fewer descendants, a fading legacy. Again, this is superstition, not science, but it reveals cultural associations. The chin is a symbol of endurance, of long-term success, of what you leave behind. In European folklore, pointed chins were sometimes associated with witches, with cunning, with deviousness. Think of the classic witch stereotype: pointed hat, pointed nose, pointed chin, all angles, all sharp, all suggesting something not quite human, not quite trustworthy. These are prejudices, harmful stereotypes, but they show how facial features become coated with meaning. How the chin, this simple piece of bone, becomes a repository for cultural fears and values. Now let's consider the chin in portraiture and photography. Because artists have long known that chin angle and lighting dramatically affect how a subject appears. Portrait photographers often pose subjects with their chin slightly forward and down. This emphasizes the jawline, makes the chin more prominent, creates a more flattering angle. Conversely, tilting the chin up can make it recede, make the face look rounder, less defined. Lighting matters too. Light from below can create shadows under the chin, making it look weak or double. Light from above and slightly forward creates the best shadows, defines the jawline, emphasizes the chin. Professional portraits almost always use this lighting because it's flattering, makes people look their best. In classical painting, the same principles apply. Artists learned to depict chins in ways that conveyed character. A strong chin in three-quarter view catching the light suggested strength, resolution, nobility. A weak or hidden chin suggested the opposite. These are artistic techniques, conscious manipulations, but they work because they tap into deep associations, assumptions we make about facial features, about what they mean. And the chin, being so visible in profile, being so prominent or not, is a key element in these visual communications. Let's talk about athletic performance and the chin. Because in contact sports, the chin is vulnerable. A punch to the chin can knock you out. Why? Not because the chin itself is important, but because hitting the chin transmits force to the jaw, and the jaw is connected to the skull. A sudden impact to the chin rotates the head violently, and that rotation causes the brain to slam against the inside of the skull, causing a concussion, loss of consciousness, a knockout. So in boxing, in MMA, in any combat sport, protecting your chin is crucial. Fighters keep their chins tucked, close to their chests, making it harder to hit, and they train their neck muscles to absorb impacts, to prevent that violent rotation. Interestingly, chin shape doesn't seem to affect knockout susceptibility. A strong chin doesn't protect you. A weak chin doesn't make you more vulnerable. It's all about the mechanics, the force, the rotation, not the bone structure. But the term glass jaw persists, referring to fighters who get knocked out easily, even though it's not really about the jaw or chin. It's about the brain, about susceptibility to concussion. Still, the association is there. Chin equals vulnerability. In combat, in confrontation, hit the chin, win the fight. It's a target, a weak point. Not because of what it is, but because of where it is. Exposed, jutting forward, easy to hit. Let's explore forensic anthropology and the chin, because when scientists find skeletal remains, the chin is one of the features they examine. To determine species, to determine age, to identify individuals. If a skull has a chin, it's human, period. No other species has one. So the presence of a mental protuberance immediately tells you, this is Homo sapiens, not Homo erectus, not Neanderthal, not any other hominin, modern human. This makes the chin incredibly useful in paleontology, in archaeology. When fragmentary remains are found, when only part of a jaw is recovered, the presence or absence of a chin can determine what species you're dealing with. Chin shape also varies between individuals, so in forensic cases, when trying to identify unknown remains, chin morphology can help by comparing to medical records, to X-rays, to photographs. The unique shape of someone's chin can aid in identification. It's not as unique as fingerprints or DNA, but it contributes to the overall picture. The suite of features that make each person distinct. So, the chin, this mysterious feature, serves practical purposes in death that it doesn't serve in life. It identifies us, tells others who we were, what species we belonged to. It's a marker, a signature, written in bone. Now let's talk about the future of chin research, because scientists haven't given up on solving this mystery. New technologies are emerging, new methods for studying evolution. Genetics is advancing rapidly. We're getting better at identifying which genes control which traits, at understanding how genes interact during development. Soon, we might be able to pinpoint the exact genetic changes that create the chin and trace when those changes appeared in human evolution. Biomechanical modeling is improving. We can create detailed computer simulations of jaw function, of stress distribution, of how different chin shapes affect performance. This might reveal functions we haven't considered, subtle advantages that aren't obvious. Fossil discoveries continue. Every year, new hominin fossils are found, and each one adds to our understanding of human evolution. Maybe we'll find transitional forms, early Homo sapiens with intermediate chin development that would help us understand how the chin emerged, what changes led to it. Brain imaging is revealing how we process faces, how we perceive chins, what neural mechanisms underlie our judgments of attractiveness and dominance. This might explain why we care so much about chin shape, what evolutionary purpose those perceptions serve. All of these approaches are converging, creating a richer picture of the chin. And maybe someday we'll have a definitive answer. We'll know why humans have chins, what function they serve, how they evolved. Or maybe we won't. Maybe the chin will remain a mystery, despite all our technology, despite all our knowledge. Some questions might be unanswerable. Some events might be too far in the past to reconstruct. And that's okay. That's science. Embracing uncertainty, accepting limits, continuing to search anyway, because the search itself is valuable. The questions matter, even without answers. Let's end with a personal reflection about your chin, the one you're born with, the one you see in the mirror, the one that's part of you. Whatever shape it is, it's unique. It's yours. It's part of your genetic heritage, inherited from your parents, from their parents, going back thousands of generations, back to the first humans who developed chins, 200,000 years ago. You're part of that lineage, that unbroken chain of humans, all with chins, all unique to our species. And your chin, whatever it looks like, is a badge of that membership. You're human. You have a chin. And that's remarkable. That's special. Even if you don't like your chin, even if you wish it were different, stronger, weaker, more defined, it's still yours, still human, still part of this great mystery. So when you look in the mirror tomorrow, when you see your chin, remember this conversation. Remember that you're looking at something unique in nature, something no other species has, something we still can't fully explain. And maybe smile, because you're part of something bigger than yourself, part of a species, a lineage, a mystery. The chin is more than bone. Its identity, its heritage, its connection to all humans everywhere, past, present, and future. We all have chins. We're all in this together, sharing this strange feature, this unexplained protrusion, this marker of humanity, and that's beautiful. Sleep well, dream of evolution, of mysteries, of the strange and wonderful journey that led to you, with your unique face, your unique chin, your place in the long line of humans stretching back through time. Good night. The chin mystery endures, and so do you. Part of the enigma, part of the wonder, part of what it means to be human forever.